Hi, my name is Drake, and today I'm going to do a quick demonstration of the principles of code coverage and unit testing, which in turn gives a quick practical primer on quality intelligence technologies. To illustrate the concepts of code coverage and unit testing, I'll be using Node.js. In particular, I'll be using the Jest JavaScript testing framework. Jest self-describes itself as a delightful JavaScript testing framework with a focus on simplicity. And this is the case. Jest is really simple to use. First off, let's take a moment to set up a basic Node.js project. So, I use the npm init command to create a new Node.js project. What this does is create a package.json file, which contains a couple fields. You can see it has the name Jest test, which is the name of the directory that I ran npm init in. And you can also see it has a scripts field, which contains another field called test. We're going to be changing this field momentarily. Now that our package.json is created, we can install Jest. We do this by using npm install and use the flag savedev jest. The savedev flag simply indicates in the package.json that Jest is a development dependency. This means in production servers, Jest won't be installed. Once this command completes, Jest is installed in your project. Next, we have to specify that our project uses Jest for its testing. Doing this is actually pretty simple. We go to the package.json file, find the scripts property, and then the test property of the scripts property, and change the existing bash script, which says we're not using tests, to Jest with the flag coverage. We're using the coverage flag because we want to generate code coverage for our tests as well. And that's it for setup. We're now ready to write some JavaScript. To keep things simple, I'm going to use the same example that the Jest Getting Started guide uses, a simple math sum function. First off, I create a file called math.js. Inside this file, I create a function called sum. I'm exporting this function so that I can use it elsewhere in my code, and we can also access it from the test file we're about to write. Inside this function, we simply take two parameters, a and b, and we add them together, summing them. This function is intentionally very easy to understand because we want to know what the answer is, and we want to know that the test is completing successfully. So, how do we go about testing this math file? First, we create another file called math.test.js. You can see the very first thing we do in this file is require math. This gives us a reference to the modules that were exported in the math file. In this case, we're going to be using math.sum. Next, we use Jest's built-in testing function called test. Its first parameter is a string which tells us exactly what we're testing. In this case, we're summing 3 and 4 to get 7. Next is an anonymous function. This function has no parameters, and the body of the function contains the thing that we're testing. In this case, we're expecting that the value of math.sum, passing in the parameters 3 and 4, to be 7, and that should be the case. The expect and to be functions are fairly standard in Jest. There are other functions that can take their place, and if you're interested in those, check out the Jest documentation. And that's it. Just like that, we have both the code and the test for that code already written. Next, we can run the test. So we simply type npm run test, which references the test script that we defined in the package.json earlier. You can see from this, Jest has done two things. First, it's completed all the tests. You can see that we have one test passed and one total. That's great. You can see that our code is actually working. Second, you can see in the little table that is built that we have 100% code coverage. Let's change that. Alright, it's time to write another function. I'm going to drop back into the math.js file I was working on earlier, and this time write another function called above10. This function is going to take in a parameter, just one this time, called num, and it's going to do one simple thing. If the num is above 10, return true, else return false. Now, I know what you're thinking. I can just say return num greater than 10. But I'm doing this for a purpose, and you'll see that in a moment. Great. Now that we have our function, let's write a test for it. I'm going to check if 11 is above 10. So on line 7, you see I describe what I'm going to do. And then on line 8, I expect that math.above10, 11 to be true. So I expect that 11 is above 10 and that it'll tell me that that is the truth. Notice that I only check to see if 11 is above 10. I don't also check to see if 9 is above 10. And the function that we wrote above 10 has a property that sum doesn't have. It has a conditional. We'll see why that matters in a moment. All right, so we go back to the terminal and we run npm run test. And as you can see, both of our tests passed, both checking if 3 and 4 equals 7 and that 11 is above 10 have succeeded. And that's what we're hoping for. But you might have noticed there's an error on this readout. In math.js, there's an uncovered line in our code coverage readout, line number 9. What is line number 9? You'll also notice that the branch factor is 50%. That means that we're only covering 50% of branches. Well, what does that mean for us? Well, let's look back at our above 10 function. You'll notice that line number 9 is the one considered uncovered, and this actually makes sense. When we wrote our tests, we only tested if num 11 is greater than 10, and in that case it returned true. But we didn't test any numbers below 10. If a number was below 10, then the conditional should fall into the 9th line and return false. So what we're missing here is a test for something below 10. In this case, let's just try 9. So we head back to our math.test.js file and we make a little change. We add check if 9 is above 10. So we expect that math.above10, 9 should be false. And there we go. Once again, when we run our test, we have 100% coverage. So every bit of code that we've written is being tested by a test that we wrote ourselves. That's great. That's what we're aiming for. You'll notice that the total testing time is a little bit long. I don't believe that's because of the tests, and instead, I believe that's because of external factors on my personal computer. A quick side note on abstraction. To properly unit test, you need to write tests. Writing tests is easier when the component you're testing is smaller. And finally, individual components get smaller when you apply abstraction. Let's take a look at an example of this. On the screen, you can see two functions I've pulled from some of my code. One prints some instruction data, and the other processes an instruction. You'll notice they both share the same first 5 lines of code, decoding the instruction into 5 different parts: the operator, the 3 registers, and the immediate value. We can do better than this. Code shouldn't be duplicated in this way. To fix it, I've simply separated the instruction parsing logic. I create a function called parseInstruction, which takes in the raw instruction that we had before. It then creates an instruction object and parses the instruction into the parts that we had before sending that instruction object back. Now we've modified our two functions, printInstructionData and processInstruction, to now use this parseInstruction function. This, in essence, is code deduplication. It's also a great example of abstraction, where we take the steps that we use to separate the instruction into its individual parts, and we put that into its own function that only performs that task. Often, we apply abstraction during code deduplication, but it's apt to consider abstraction even if there's only just one use so far. Notice that when we were writing the above 10 function, adding one more conditional doubled the number of tests we needed for full coverage. This can often be the case, and it can be even more than double sometimes. Generally, the more monolithic the code, the more tests you'll have to write to cover everything. Try to keep your functions small.